Question 18, 8 to the power of 0. Once again, we know anything to the power of 0 is 1. 5 to the power of minus 2. That's a reciprocal question again. So we know that's going to give us an answer of 1 over 25. 27 to the power of minus a third. So I've got to do a reciprocal first. Write it as a fraction over 1 to the power of minus a third. Now let's remove the reciprocal, the minus, by flipping it. 1 over 27, all to the power of a third. Now that means the cube root of 1 divided by the cube root of 27, which will be 1 over 3. Next question. 25 to the power of a half is just equal to the square root of 25, which we know will be 5, and that goes on the dotted line. A slightly more challenging question. X is equal to 2 to the power of k, and the square root of 4 over x is equal to 2 to the power of c. So let's start by substituting x over 2 equals 2 to the power of k into our expression. So we get 4 over 2 to the power of a k, and all of that is square rooted. And let's simplify that as much as we can. So both of them need to be in powers of 2. We know 4 is just going to be 2 squared. 2 to the power of k, well, we can rewrite that as times 2 to the power of minus k, because it's a reciprocal, and all of that needs to be square rooted. When we square root, we're actually taking the power of a half, so each of those, 2 squared to the half times 2 to the minus k to the power of a half, leaving me with 2 to the 1, because half of 2 is 1, minus k divided by 2 will be 2 to the power of minus k over 2. If I add the powers, I'm left with 1 minus k over 2, and that is equivalent to my c. Moving on, writing as a power of 5. 5 to the 4 times 5 squared, we add them. 5 to the power of 6. 5 to the 9 divided by 5 to the power of 6. Take them away. 5 to the power of 3. Part B. When I multiply 2 to the power of x by 2 to the power of y, I get 2 to the power of 10. That tells me, because when I multiply powers I add them, x plus y must be 10. When I divide powers, 2 to the power of x divided by 2 to the power of y, I get 2 to the power of 4. I'm now going to be taking the letters away because I subtract when dividing, and that leaves me with the number 4. Now you could use trial and improvement for this. So x and y have to be the same numbers. When I add them I get 10, and when I take them away I get 4. The only pairs of numbers that would work for would be when x is 7 and y is 3, because 7 plus 3 is 10 and 7 take away 4 is 3. Question 20. X is equal to 2 to the power of p and y is equal to 2 to the power of q. Part A. Express in terms of x and or y, 2 to the power of p plus q. Well, we know we add the powers only when we multiply. So that's 2 to the power of p times 2 to the power of q. In this actual fact here, we know x is 2 to the power of p and y is 2 to the power of q. So my final answer will be x times y, which can be written as x times y. On part 2, we only have 2 to the power of 2q. So what I'm going to do is separate that out as 2 to the power of q all squared, and we know 2 to the power of q is y, and when I square that, I'll get the expression I'm looking for, y squared. 2 to the p minus 1. On this occasion, we know that's 2 to the p times 2 to the minus 1. Minus 1 obviously means 2 is a fraction because it's the reciprocal function here. So that's equal to 2 to the p divided by 2. We know 2 to the power of p is just x, so my final answer will be x over 2.